Division of rational expressions. We let P, Q, R, and S represent polynomials such that Q, R, and S are not zero. So then we could say that the fraction P over Q divided by R over S can be changed to P over Q times S over R, and then multiply the numerators and denominators together and simplify as needed. So when you are dividing two fractions, you have to change it to multiplication in order to simplify it correctly. To do this, you need to keep the first fraction as it is, change the division sign to multiplication, and then flip the second fraction. So an easy way to remember this is when you're dividing two fractions, you need to keep, change, flip. Afterwards, the same rules for multiplication of rational expressions follows. So 4x divided by 7y divided by 2x squared divided by 21xy. So I'm going to rewrite this by keeping the first fraction, changing it to multiplication, and flipping the second fraction. And then just like with multiplication that we did before, just cancel out like terms. So I see I have an x here and an x here up top, so there's two of them, and there's two x's down here, so I can cancel out all of the x's. Next I see a y and a y, so I can cancel out a y each from top to bottom. I got a 7 and a 21, so I can say that 7 goes into itself once and a 21 3 times. And then 2 can go into itself in 4, so 2 into itself once, and 2 into 4 twice. So from here, 2 times 3, because that's all that's left up top, which is 6, and then 1 times 1, which is just 1, so I can just leave the answer as 6. Next, 8m to the 4th, n to the 5th over 5n to the 6th, all divided by 24mn over 15m cubed. So again, I'm going to keep my first fraction as is, change it from division to multiplication, and then I'm going to flip it. So 15m cubed over 24mn. So let's do some simplification. I see that I have 1 m in the bottom, and I have 3, 4, 5, 6, 7 up top, so I can cancel out one of the m's here and one of the m's here, so left with 2. My n's, I have 5 n's up top and 6, 7 in the bottom, so I can take out 5 here and I take out 5 here, leaving me with 1. I can move on to my numbers, or my coefficients. So 8 and 24, I can take 8 and divide it into itself one time, and 8 can go into 24 3 times. Then I can say that 5 can go into 15 3 times. So 5 into itself once, and 5 into 15 3. And honestly, this is starting to get a little bit much, so I'm going to kind of clean it up before I see if I'm finished. So m to the 4th, an m squared, and a 3, so 3m to the 6th, and then an n to the 1st, and another n to the 1st, and a 3, so 3n squared. And from here, 3's can actually cancel each other out, so I'm going to do that. 3 into itself once, and 3 into itself once. So I'm going to end up getting m to the 6th over n squared. And that should be it for that one. Next I have 4a plus 12 over 6a minus 18 divided by 3a plus 9 divided by 5a minus 15. So again, I'm going to keep the first fraction as is. I'm going to change it to multiplication and flip the second fraction. And so I'm going to factor the top, 4a plus 12. I can factor a 4 out, and I have a plus 3 left over. In the bottom, I can factor a 6 out, and I'm left with a minus 3. Up top again, I can factor a 5 out, so a minus 3. And in the bottom, I can factor a 3 out, a plus 3. So let's start canceling what we can. The a minus 3's gone. The a plus 3's gone. And I can see that 4 and 6 have something in common, which is a 2. So 2 can go into 4 twice, and 2 can go into 6 3 times. And I don't see anything else I can cancel, so I'm going to combine. So 2 times 5 is 10, and then 3 times 3 is 9. And that is these two fractions simplified. Last, I have p squared minus 2p minus 3 divided by p squared minus p minus 6 divided by p squared minus 1 divided by p squared plus 2p. So again, I'm going to keep the first fraction as is, change it to multiplication, and flip the second fraction. So the first fraction can be reduced down or can be factored down to p minus 3 and p plus 1. The second fraction can be reduced down to, or factored down to, p minus 3 and p plus 2. This can be simplified or factored out to p and p plus 2. And we can factor p squared minus 1 as the difference of squares, p minus 1, p plus 1. And so I will cancel out like terms, p plus 2's, p plus 1's, p minus 3's. I don't see anything else, so I'm just going to write out what I have left, which is a p up top, and what I have left in the bottom is a p minus 1. And this cannot simplify any further, so this is these two rational expressions simplified.